Hi. Hi, Yusuf.
Hi, how are you?
Fine. Sorry for the delay. There's something came up.
No, no problem, no problem. It happened this weekend. We need to remember this. So
Yes.
it's obvious things. So how's going?
Everything is fine. Ah,
Okay. So can we start?
yes,
Or
yes.
you have any question?
No, I think you have clarified in that call.
Okay, okay. Nice, nice. So let's see. Hopefully we'll do good. Okay.
Yes.
So you call out your name as Prasad or Jena. Jena is your surname?
Jena is my surname.
Okay. So you call yourself as a Prasad, right?
Yes.
People call out. Okay. It's okay. So let me call out you as a Prasad. Okay.
Yeah.
Let me see if I have started recording. Are you able to see? Like it's saying that call is getting
It
recorded.
is recording started. It is showing recording has started.
Okay. Okay. Fantastic. Welcome to NextGen Tech Talk. We have Prasad today with us, and we are going to talk many things which we never spoken about. So let's start the discussion. Welcome, Prasad, to Next Gen Tech Talk.
Yeah. Thank you for having me.
So your smile face says that you are very excited, and this topic specifically, which usually we pick up on this podcast, is AI. So you are enjoying it along with AI.
Yes, we can say like coming from the AI background and being frontier of the technology. So
Mhm. Yeah, perfect. Okay, so to start with, Prasad, can you introduce yourself, just like from where you have started your journey and what heavy lifting you do, how differently you do your work, and if you want to highlight any complex work which you have done so far. So just 1 or 2 minutes, so that viewers can have a fair understanding about your profile.
okay, so my name is Prasad Jena. I'm currently working as an AI ML engineer here at OEV, where I mainly works on the disease prediction. So we are trying to develop autonomous AI, which can help the doctors where doctors cannot reach certain places. We can mass screening the patients. So, if you're coming to my background, I have completed my bachelor's in mathematics. Then I have completed my master in mathematics and computing from IIT Guwahati. So, for some of them, it is little bit different from the usual way whoever doing AI, because everything more of people's coming from BTech background, BTech computer science as this, but coming from the mathematics, then mathematics computing, though it is
Mhm.
little bit different, but underlying AI, everything in the heavily relies on the maths part. So that
Right.
get me help on that part. And uh, the question you asked about the key projects or key findings. So because of my maths background, so I'm actually not stay in one position. It's more like a holistic view. Like I sometimes work on a pure algorithm base where math is much more needed, or where the ML side is needed, and sometimes much of like a hybrid kind, you can say, maths plus
Mhm.
computing, where you leverage your math knowledge. So like if I give a certain example, so where I have worked on the math part, so we see the Google Maps, how it
Mm.
is predicting the route, shortest route. We know what the main algorithm, that disaster algorithm that they use, but still there are so much maths going on. So I have used the maths plus ML on those parts as well for the EV,
Mhm.
where because predicting the actual range, not just a random range on the that. And apart from this, I was working multiple projects in Gen AI, ML course
Mhm.
side, and chat bots, voice bots as well. So that's
Okay. Great. Great. So we all understand that some of the other, we are solving problems, right? Uh, or in different way, if you look at it, like we are the solution provider. So you you also work on the team? Just if may I ask you,
Yes,
or
yes.
you are individual control? Okay. So when your roles comes in, right? So how you start your work? Because in back of your mind as a AIML engineer, right, or practitioner, you know that I'll solve the problem utilizing some of the other tools, technologies, right? But from where you start your thinking while looking at the problem statement?
So I mainly, actually, I heard somewhere where it was written Bill Gates used to do.
Mm,
So I actually follow that. If the problem comes, I ask myself three questions. Is it a problem already there? Someone has faced, or what? How they have solved it? How we can implement it? If it is not there, it is new kind of problem. How can approach it? At least approach. We don't know the how the solution, but at least the right way to, okay, this direction we have to go. So these are the primary three things I have asked, that I have read on somewhere, that Bill Gates used to do like that. So it's pretty much from my, you can say, in under my bachelor's time, I used to follow this one.
mm,
So, like, most of the problems lie in the first two categories. It is already there, someone has solved it. Maybe you need
mm,
optimization, but in your case,
mm,
might need add two, three more points to that. But most of the problems lies on this, because AI is a so much diverse case, and there are so many things going on simultaneously. It's not like you are the first one who are doing. Someone might be
mm,
doing simultaneously, might not have published it. But for the third kind of the problem, which doesn't have any clue, you ask GPT, or there is no, that needs new kind of approach. How it
mm,
should be done, how should we approach it? So as an engineer, normally people used to do what is the previous problem we used to solve. But because of this new problem, you have to solve what is the future problem. How, if you try to solve this, what other problems might arise from this? So you have to take
mhm,
care of. So while doing the solving this problem statement, how should I approach? You have to take care of all the other problems might generate from you, like, because let's
mhm,
say there is something in AI side, deployment issue, or you are to deploy it. You can, okay,
mm,
we'll use the resources to, okay, deploy it, will do. But you have to see the futures also, like you have limited resources. Is it time consuming? Is it cost effective, like that? So this is
mm,
my primary approach. And yes, other team members are there also to give input,
mm.
how they have handled that. That's where the experience comes in.
Right. Well thought, Prasad. I think it's always important that you start wasting time when you are trying to reinvent the same wheel. Number one, and of course there is no learning at all while solving the problem. Many times we our approach is and our thinking is, what is the learning point here, right? Because see, once you are doing any repetitive work, that means automation can be done there, right?
Yeah.
And if automation, whether you are referring something, as you have already mentioned, that if you are searching and you got that someone has already built it, so simply just adopt that, right? So, and that is the reason even the business people, they follow build and buy. So wherever there is something already built, right, built, then they prefer to buy it, so that they can save some time. And if something which they think that this is not only the reason that they want to build, that something is already there. Sometimes we need our proprietary, right? That I have built this as a product company and stuff like that. But yes, from the engineering point of view, definitely yes, whatever you have articulated, that is the right approach. And I think when viewers is going to hear you directly that this should be the approach, so they will think that this is the early stage when we should identify these approaches, right?
Yes.
And these are the basics. These are the basics. If you are not following all this, meaning you are not in line and you are not on the right path. And maybe one day you will encounter something and then you will change your approach. So something like that. Okay, very nice, Prasad. Um, so how many total years of experience you have, Prasad?
So I have almost 3 years experience in
3
AI ML
years.
field. Yes.
Okay, okay. So in 3 years, you must observe that things are rapidly changing, right? Or maybe upgrading. So how you prepare yourself that I should not be behind, number one. And number two, even you are behind, then how you think that what should be your approach to catching up quickly?
Yes.
Because this is going to change your outcome.
Yes, yes. So I'll start by, so when said I have come from maths background. Actually, I joined my first company as a software engineer, but coming
Mm,
from the maths and computing background. My manager who insisted me to go into the ML one because you have the
mm,
maths strong. So though at that point of time, it is I think early 2023. So I started that time AI started to hype, but it is not that much of, still there is a scope. But that point, I when I joined the ML field, then I know there is a this diversity and this many things it is happening.
mhm,
So when you see so it is a very fast facing, there are so many things are happening, you shouldn't fall behind and this thing. So one main approach I found out that if you try to achieve all it, I want to know everything and apply, that will not get you anywhere. It's like you want to try master a jack of all trades and master of none kind of. But in this fast facing, you don't need to be or doing all the things, just pick the one thing, be there in your expertise, be top 1% or top 2%, then no one can beat you. Though they might
mm,
have multiple knowledge, but when it comes to certain field, you are the one who they will be
right.
calling you, who they are referring to, because they know you are the one, you know how the
Mm,
things are actually, how it's implementing. So the main thing is, I instead of diversifying myself, okay, this is this part, this is this happening, I should go to the engineering aspect, I should go to the theory aspect, I stick into that. Okay, I should be applied more AI plus ML field. This is my frontier. I know so what should my in the my particular domain. I Yes, I will have other knowledge as well. Reading this as paper to up to date what people are doing, but in the one line, I will be the best. Now, if not the
mhm,
best, I will be at least same label as them. So I
right.
am keeping that in mind.
Great. Great, Prasad. Uh, Usually, I don't focus on the domain specific topics, but this is very interesting that healthcare, specifically healthcare, because this is related directly to the human life. It's not like human assets and their day to day basis activity or need. It's about their life. So how you see that AI is best fit for the healthcare because it's just a matter of the error factor. The moment error will be little high, like if you are thinking that okay 0.5% or maybe 0.001% minor error is fine. But if this increases because of the engineering, then someone life can turn into something else. So as you have already mentioned that you are working in the same domain, right? So as an engineer, do you think that we should, or you are already, keeping multiple governance models or maybe checkpoint through that you always monitor that few things cannot go wrong?
Yes.
Many times we develop the application, right? Simple application or complex application. We think what will happen in worst case scenario, we'll recover from here and there, right? And we do. Is everyone does like everyone do because it's not like uh, system cannot do mistake. But in case of healthcare, what are the precautions according to you take and you are advising for developer engineers who are working in the healthcare domain that as a practice we should do that at the very first place.
Yes. So I'll start by, like, if it is not a healthcare, people used to do, if we have developed something, a
Mm,
software or AI software, whichever, we always can say it is a glitch, or resolving it is simple as that. So there is, though there is money loss, financial loss, stress is there, but there is no human life loss. But when
Hmm.
coming to the healthcare domain, it's become much more complicated. You can't say it is a glitch or it is a just a
Yes.
hallucinated, then it you
Hmm.
are the, as you said, the human life in this danger. So there comes the multiple, like when I am working on the healthcare domain, so it
Hmm.
depends on the disease case. Like if it is a simple, let's say you are predicting a cold, if it is actually cold, so if you miss a case, it's a false negative, means if you missed a case, it will not impact that much. But if you miss a cancer patient case, if you are using AI,
Absolutely.
so it
Right.
depends on the disease part. And the second part,
Hmm.
when you are when we are building AI, there is multiple stages. It's called class C, class D, but it's technical part. But you can say it is a assistive or autonomous. Sometimes it is
Hmm.
assistive, where doctor will do the primarily thing, heavy thing, but AI
Hmm.
is more like a tool where they can use it to simplify their things. It's more like
Hmm.
you want to hole a wall. Previously
Hmm.
they used hammer and the snail. Now you have
Right.
this black hammer, you can use it.
Absolutely.
So the people will the same, but they will change because it's life easier to use the electric machine. So
Hmm.
there is no actually robotic which will automatically do a hole. They will just use the machine.
Hmm.
So this is the
Hmm.
assistive stage. But while coming to the autonomous part, there where this part gets tricky. There you the disease comes and every, because there is doctor, no, there is no involvement of doctor, and you say this patient doesn't have disease, and they found out later this has disease, and it progressed to much more higher state. Like for a cancer state, you say you are, it is a earlier
Right.
stage, you have said, oh, you don't have it,
Hmm.
then they
Hmm.
have progressed to the final stage, then you can't have
Hmm.
it and that patient is lost. The,
Right.
it's not about the AI, then it's depends on integrity, how you have developed. And
Hmm.
so we try to minimize as much as the uh, final stage cases. Like if I say example, there is early stage, there is a final stage. So we don't want to miss the final stage, because those are the main critical area. If those miss, that immediate consequences are there. But when we're developing AI also, there is like humans also, it depends on the how much experience human doctor you have, or how much new
Hmm.
doctor you are with. They also have this the, what you dependability. They can say someone said this has a disease and other one says not has a disease.
Right.
Those
Right.
actually came in the middle cases, like borderline
Hmm.
cases, when there is a
Hmm.
little bit early stages, and for the no disease cases stages. So the
Hmm.
model also, because AI is what we are just trained according to our human
Hmm.
brain, how we understand. It
Right.
just those
Right.
data set and model try to understand how he thinks. So whatever, uh, if they might have more for what you say failure than we have, but whatever we might cause to okay misdiagnosis, they will have the same thing. At least they will have as much as falsehood like we have. So we try to develop that. So but yes, cancer I told as a very big disease, but we have started with some early. So
Uh-huh.
what I've been working on this eye part, where the diabetes leads to the blindness. So
Hmm.
there are multiple stages. So the severe
Hmm.
stages where you have it, if you don't get a treatment now that of time, you lost your eye vision. Then
Hmm.
I am, if you see in India, where most of the mans are the middlemen, and for them
Right.
losing an eye, it's like you can't work. Like
Correct.
there are people who can, but if you say in a majority, eye and
Hmm.
hands, those are the majority things. So you can't
Hmm.
lose those people. There are some cases where AI gives okay wrong outputs. They say uh, this guy hasn't has disease, but we later found out disease. So that
Hmm.
though it is not a severe case, still we are missing it. So what we try to do is we try to minimize our threshold. So we want to do it like we don't miss any of the cases. We might give some patient as it has a disease, but it doesn't has actually, which might cause patient anxiety, referral burden to doctor, but because they have to see more patients which are not actually disease patient. But still
Hmm.
you are not losing any life, though there is money
Right.
loss, there is anxiety, but that is a utility case. So I think
Hmm.
coming to the healthcare part, we have to see instead of utility safety, user safety first. But if you see Amazon, Flipkart, or some any software, they are see utility. They want to maximize as much as people they want to capture, though there is minor glitch is there, they are okay with it. But in healthcare domain, you can't afford to have a minor glitch or minor. It's better to have a, what you say, uh, non-disease patient mark as a disease patient and let it go to the doctor to, okay, then later to find out he is fine, to then rather than the disease patient to you are fine, go roam it and later you find it. So that is the main approach. We are
Right.
little bit conservative, though it is not economical, but it is a patient wise
Hmm.
it's very good.
Yeah. Right. Yeah. So, my point here is a little bit different. So, idea is, you know, you build your AI model specific for you specific use cases. So, what that means is you have a lot of data there in the background, right? Which works and check the cases, right? Now, assume there is one patient case having a differentiation of even a minor percentage. So, as you have already mentioned that if we consider that probability and push that to the human, meaning the real doctor.
Mhm.
So even simple viral, if system is predicting that this person has, so whatever the confirmation from the data point of view we are having, after that, if exceeding any point, then it should recommend to doctor that this data set is not available, something like that.
Okay.
And I think this should apply only for the medical care or healthcare, because precision is the key in healthcare. So we cannot take risk. I think as of now, I just want to move from the healthcare path. Otherwise, it will be a detailed debate on only the one domain, because our main focus is how AI is, building a support system for entire domain, and healthcare is not the first one, last one. I think the first one is started long back. Maybe we as a human came to know at the later stage that how much automation, how much AI is involved there. But yeah, I think you also aware of that. The only thing is we keep collecting the data. Now data is also getting very big, right? So I think precision, data modeling, regression, and then data quality is also important.
Yeah, quality, yeah, quantity
Yeah,
over
yeah.
hours.
So maybe you have a lot of quantity, but slowly you need to get rid of those data which are redundant and not applied now.
Yes.
The type of disease we had earlier and now is having a big difference, right? So those data needs to be corrected time to time. That is also important. Anyways, so Prasad, you you are already doing heavy lifting at your workplace, but anything which you want to share as a tips or suggestion to the viewers, if they are going to start their career and they have focused that okay, I want to get into the healthcare domain only because this is the domain which is never going to end. They need always support, and they must need the engineers and person who can give them lifetime support, something like that. So, what suggestion you are going to give to them?
So I hope this is only for the people who are starting now, means college graduates and this
Right,
thing.
right. Yeah, yeah.
Before coming to the healthcare domain part, I want to give a general. It is not advice, but it is you can give a point of view of mine. So
Mm,
because it's AI is so fast facing and people are moving so rapidly and growing, and
mm,
like our generation has this tendency, so you want to achieve it and we have to know it all at once. Like I have already mentioned that just focus into the one point, because of, okay, healthcare is there, I want to know everything, whatever whoever done as a higher level research, I want to implement that. But
mhm.
everything is comes down to basic. Don't need to
Right.
be start too hasty. You can start slowly and just see what are the basics, because however much label you go, the basic is the
mm,
main.
yeah,
Because everything is built from the basic. If something breaks, you know in the basic what happened. It's more like
mm,
a root cause. That's when you bring a plumber, if the
mm,
tapping they know where that might have happened, the main thing, because they know the basics. But if you know, okay, if you are the person, you know the overall flow, okay, this there is a tap coming or water is coming, you will not able to figure it out because of why water is keep on leaking. The same goes to the AI part. So some things go wrong in the healthcare domain, how it is should be, you know the basics. Patient is priority, there is called patient health information, PHI you call it. So patient health
mhm,
information as also that much important as the patient diagnosis. Like if you see in USA, so they have this mandatory form, 2 page 3 page, they
mm,
will take everything, whatever small disease you have this you
mm,
have this thing from the childhood, you have this disease, they have a long form. Like unlike India, we are not following, but it is keep on going that because of we have so much population and we have to diagnose so much people.
mm,
But the patient health is the main thing, because without the data, though you have some data, but underlying those data why it is came, if
correct,
whatever you do it might mislead you. So the you have to see whatever information you have or what you can inform those things. So those are the main things. And coming to the healthcare, you say, so you have to, you are only a part of engineer or a software team, you will be also working hand to hand with the doctors, how they
mm,
think, how they want to perceive on what they are extracting. You have to capture all those as much as possible to feed into the AI, how you can feed
mm,
these parts, because those are the insight. Because it's more like a, when you're riding a bicycle, I have already know a cycle how to know a bicycle. If you ask me how to ride a bicycle, I say just use the bicycle and just pedal it, it'll going. But that's not
right,
how it's, like if I someone bring who doesn't know bicycle and I tell the same thing, just pick the bicycle, ride as high as pedal it, it will go, no, he'll gonna fall off. It's like that. So though there are some inside their mind something is going on which they have accumulated through the experience, they're not able
mhm,
to say. But then you have to capture, you have to ask more questions, how you can capture, you have to get the quality of data, diversify the data.
mm,
So there is a point you need at least this much data, because this is a very high healthcare or AI needs much more data, but the diversity is
right,
also a point. Because if you have much more quality data, you can get all the edge cases, how it is differing from this to
correct,
this. So those are the
correct,
main cases. So you have to get capture all those things from the data, from the doctors, from the experience or anything research going on. There are so many
mhm,
things going on using LLMs architecture in using the in image part. As much as you can get the diversity and as much as you can feed it, that will be
right,
the main to focusing
right.
main on the patient part. Yes.
Exactly. Yeah, you have taken a good example because if you want to get into the root cause analysis, that cannot be happen at the very top level investigation. Definitely, you should get deep dive, and then only you can get into the root. That what is the major problem? Why this happened and that happened? So I think basics are basics. Prasad, right? If we forget, if we miss, we try to ignore, definitely we are going to hit the consequences. So this is important. And so w- in terms of models, what models you prefer?
So models, as in, if you say like you are
LLM,
developed,
I'm talking about. Yeah. Mm.
uh, so depends on use case to use cases. You have
Okay.
text data, you have image data. Like there is not, you cannot call as a model, but more like a architecture which we define
Mm.
use more. So which architecture? Like I am now primarily work on the image data. So there are CNNs there. So there are multiple CNNs. There now they are introducing, like it is, though it is earlier introduced, but now it is coming into the picture. Transformers in the image means what you are
Mm.
doing in a like chat GPT Grok, what they are doing, the attention based mechanism, the same thing we are trying to apply in the image chart. So it will know
Okay.
to relate, because data is everywhere, image is everywhere. The good data scientist or good AI engineer who can find a pattern inside that, that's why they're hire so many data scientists, data analysts, business analysts, because they want to see what actually data is. Data is keep on there, so image is there.
Mm.
So you have to
Right.
capture those architecture which is best. It might change use case to use case basis, but yes, if you like what currently trends is, if you are working on some text data, so
Mm-hmm.
you can say, for instead of hit and try, start from the simpler model to going to complex model. If it is text data, just randomly you can go to the random forest or XGBoost. So because those are the
Mm-hmm.
best of the best for now, what we
Okay.
have there. So if you go to those models, you most likely you will gonna achieve what you are thinking. And all the
Mm.
now recent research papers and whatever they do, they mostly work on the tree basis. In the what
Mm-hmm.
happens in the tree basis, it's more like a consensus basis algorithm. So instead of
Right.
fitting a curve, it try to see the different aspect of it, not
Mm.
want to predict seeing all the data, but part of the data, because part of
Right.
the data might, some of the data might be more important the other part of data, which is called feature importance
Mm-hmm.
as well. But coming into the image part, then it becomes tricky, because if you see
Mm.
now also the current state of the art model, still if you give some of the color sets to, it says Gemini or some, they also still they are not able to predict it the color correctly or some object
Correct.
correctly, because I want to say like how the image is trained is, we have so much
Mm.
larger images.
Absolutely.
Any of
Absolutely.
the
That is the key.
none of the model has trained on the larger image. They have trained on 512 by 5, like this passport size photos.
Correct.
So when you have so much, let's say it is a giraffe, very, and you have
Mm.
to just capture it inside this, so some details will lost. So you might capture those by a metadata or labeling, but still you are
Correct.
losing the data when you are compressing it.
Absolutely. Absolutely.
Those,
Yeah.
that's where the model gonna hallucinate and these things are happening. So you have to
Yeah.
see the approach. What is the use case? Is it your healthcare, or is it a, maybe you are working on some fintech or some platform like Flipkart or so product related. So you have to see which is best for the use cases. And yes, there are so many state of the art models currently being worked on. But yes.
So that's the difference, Prasad. As you have rightly mentioned, we called natural and one is artificial. So natural intelligence versus the artificial intelligence. So whatever you see from your eyes,
Uh,
right around you, around the nature and all those stuff, and now you are taking the picture and then training the model. So definitely there will be a difference always. There will be a difference always. Okay. The main question coming to your side is, we solve the problem as a AI ML engineer, right? But what problem you see majorly, maybe you can give ranking that this is the of very often problem I see in my career. So what is the biggest challenge if we talk about one?
Uh, if you say biggest star, I'll go with the data part of it while
Mhm.
training AI, because I think the data, because model is, it's easier now. We have so many state of the art models which they can write the code very analyzed. So you
Ah,
don't have to be a hard worker, you have to be a smart worker. Okay, so you have to see the data and prepare it. Then after that, coding part is a 10% of your work. It can be written in
correct, correct.
5 minutes
Yes,
only.
yes.
You don't
Yeah,
have
yeah.
to sit one day to figure it out. What are the things you have to do? So
Hmm.
it is here comes into the data part. So collecting the data, cleaning the data, sorting the data, giving a label. Mislabeling will happen from however you collect the data, because if you're collecting, let's say, comments, there will be some who's give
Hmm.
fake reviews, or if you are collecting doctors also, there will be also some wrong review labels as
Hmm.
well. So data is the main part. So you have
Right.
to maximize the quality of data and quantity of data as a way, so model can understand whichever model it
Hmm.
is. Because it's better to have a good data with a, let's say, simpler model which can give a
Hmm.
better result, with to have a very low quality data with a
Right.
higher capable model. Still it is not, it's more like
Hmm.
a it depends on the driver, not on the car. The car is a part, but still, if you don't, your driver is itself is not competent enough, or you can say
Good
in
example.
our case the data is not competent enough, then what will do?
Right.
But data preparation and keeping in the same format, accessible, reusable, how you are interpreting the data before training a model. Is it a data actually sufficient for the model? Doing correlation, doing removing the data features. There are so many techniques. So those, I think that is the main part. The data I will be more focusing on.
Cool, cool. Okay. So there are a lot to talk, Prasad, but we have a time limit, right? So, but a very interesting discussion, conversation with you, Prasad. Um, I think we'll have the part 2 conversation very soon.
Sure.
Okay. Yeah.
Yes.
Thank you, Prasad. Thank you for your time. Um, and I think whatever you have mentioned during our conversation, definitely there will be a takeaway for viewers, and they will be able to connect that how professional are dealing with the things, what is their recommendation. Still, they are doing their work successfully, but still there are do's and don't which they're supposed to follow.
Yeah.
So, yeah, thank you very much.
Yeah.
Thank you,
Thank you.
Prasad.
Yeah.
Take
Thank
care.
you.